Hey guys, we are working on some applications for quadratics. So let's look at our objective sheet and see where we're at and what we're going to do in this video today. So today we are going to look at some applications of quadratics. We're going to look at maximums and minimums, which is another word for the vertex, and then we're going to look at a projectile motion. It may take us 2 videos to do this, but this is the goal of this particular video recording session. All right, so that's where we're at. And one of the problems has a lot of decimals in it, and I wanted to also show you this new method for quadratics. So now there's a video assignment posted or almost posted that is just on this new method, and one of them is the actual creator of the method video, and then one of them is me working several examples. Okay, but the method is here on your sheet, and you can just follow what's on the sheet. But one of the problems that I'm going to do in this application section, I'm going to use the new method. And the reason I'm doing that is because the new method is going to work better with all these decimals that we have to deal with, in my opinion, than the quadratic formula might. But you, of course, can use the quadratic formula anytime you want to. So just so you know, I'm going to use the new method. Okay, so let's jump in and get started with our first example. Our first example is going to deal with the situation of projectile motion. And this problem, it starts out, it's number 10 on your homework. And so just look at your homework to see where I get all this stuff from, okay? And so it gives us a function for the height of a ball that is thrown. And this function has decimals. So go ahead and get that calculator warmed up, because we will have to deal with these decimals. So now the question asks for a couple of things. It asks for the maximum height, and it also not the maximum height, but how far away from where the ball was thrown. So, and it's also going to ask for a graph. So here's a pitiful looking graph. Let's try again. So a ball is thrown from a height of 7 feet. So I'm going to start here, and I'm going to throw a ball upward and outward, and it's going to look like that. That's the path of the ball. Okay, this is my f of x, this is my height, and of course it started at 7 feet. So that is where the 7 is. Now, the vertex of this parabola is here. That's the vertex. Okay, and that's the maximum height. But it travels a distance outward. So this is our horizontal distance. I can't spell horizontal. There we go. Horizontal distance from where it was thrown. Okay, so I'm standing here. I throw the ball, and boom, there it goes. I'm throwing the ball. So how far away? Oh, I got some long legs. There we go. How far away from this is where we're going to look at. All right, so this is our x-axis, and this is our vertex. And so we want to know the height and how far away from the point of release this height occurred. So we're going to do the vertex. So we've done this. We know that the x member is negative b over 2a. So that's going to be negative 1.7 over 2 times negative 0.2. Again, you are going to want your calculator. And using your calculator, you get 4.25. Now this is the x. That is the x value of it, and this is feet. Okay. Then we will do the y value, where we actually plug in the 4.25 into our function. And again, you will need your calculator to get all of this correct. So get good at it. Stop the video and see if you can't get these numbers to come out on your calculator. This is what I got on my calculator. I'm not going to say them all. And I get, all right, so those are my two numbers, and this is my y. So let me make sure we understand what this is. All right. And so it says round to the nearest tenth. So please make sure that you do that, or it will mark your answer wrong. Okay. So the first question says, what is the maximum height? All right. So that is this answer. Rounded to the nearest tenth, which is 10.6 feet. The next one says, what is the distance from the point of release, which is this number right here. And that's the distance from the point of release. And that's going to be the x number, again, rounded to the nearest tenth. That's going to be 4.3. And this is feet from the point of release. Okay, so now that didn't seem so bad. And I can't spell release, but that's okay. It's just math, y'all. That's why it's called just math, y'all. Because I'm just good at math. That's all I do. It's just math. Okay. All right. So now we're going to go into the next part of the question. The next part of the question asks us, how far does the ball travel before hitting the ground? And this is something that we need to talk about for just a second. This is where it hits the ground. And we want to know how far away that happened. Okay? And so the height at this point is 0. When it hits the ground, the height is 0. And remember, our function represents the height. And so when we're doing how far before it hits the ground, we are actually setting our function equal to 0 in solve. That's what that means. This means the ground, h is 0, or f of x is 0. So we set equal to 0 and solve. And so this is where you could use the quadratic formula if you wanted to, or the new method, which is what I'm going to introduce. So that is what I'm going to do. I'm going to set it equal to 0 and solve. Again, if you need to stop the video right now and solve it using the quadratic formula, that would be awesome if you wanted to do that. Or you can watch me use this new method, because that's the method I'm going to choose. So I'm going to solve this. All right, my A, B, and C. I know my A is negative 0.2, my B is 1.7, and my C is 7. Now the new method is going to take into the effect of negative B over 2A plus Z, negative B over 2A minus Z, and that's supposed to be equal to C over A. I solve for Z and then plug in for my answers. Okay, so here we go. So I've already done the negative B over 2A, so I'm not going to redo that. That's another reason to choose this method, because I've already done that. Negative B over 2A, I've already done. That's 4.25. So this is another reason why I'm going to go ahead and use this method. So I'm going to have 4.25 plus Z and 4.25 minus Z. And that's going to be equal to 7 over negative 0.2. All right, I'm going to multiply this out. All right, I'm going to do a FOIL, and I'm going to get 18.0625, all right, plus that one minus, or actually minus and then plus, but that's okay, you get the picture. Those two are going to cancel out. Minus z squared is equal to negative 35. So I'm looking at 18 Okay, so now I just got to solve for z. Okay, I'm going to just flip-flop the z. I'm going to add 35 to both sides. And I'm going to add z squared to both sides. Okay, so I did that. And so then I have 53 is equal to z squared. So now using my calculator, z is equal to the square root of 53.0625, which I'm going to not write down. And it's going to be the plus or minus, this is what z is going to be, 7.2844. Okay, so now what's my answers? All right, my answers are 4.25. Remember where that came from? That's that b over 2a plus 7.2844 and 4.25 minus 7.2844. Except, dun, 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 we don't need this one because that would produce a negative. And in our context, a negative does not make sense. So go back to your picture here. This is the number we're looking for. And that's a positive number. This is the negative number. We don't want that one. Okay, so now that's going to be my answer. And that is 11.5344. Now it says round to the nearest tenth. So again, I'm going to round to the nearest tenth, and my answer is 11.5. All right, 11.5. So now let's look at our picture because it also asks for you to do a picture. So let's go back to our little picture here. And this is 11.5 right here. We just calculated that. The maximum height is 10.6 or 10.6. All right, and then this distance right here is 4.25. So now when I'm looking at my graph, this is what I'm going to look for. I'm looking for a graph that has those numbers. A 7 there, 10.6 at the top, and 11.5 at the bottom. So look for your graph that has those approximations, and that'll be the last part of this problem. A lot of answers here, so make sure you go through and look at them and figure them out. Let's see. Here's an answer. Here's an answer. And here's an answer. And then, of course, the graph is an answer. Okay? So, good luck with this. Lots of decimals. But, hey, it's just math. It's just a calculator, and you can do it. All right? All right. We'll have another video in just a few minutes.